Okay, so now we're looking at 12C, the even numbers. That's the first video there on. So the question says that BC is parallel to DF, which means to say this angle is equal to that angle, alternate angles. Of course, many other things, co-interior and there's no corresponding but alternative a different way and so on. All those things are equal, okay? Just I mark one so that I have an idea what is parallel by one glance. So which one of the angles are equal. So DE, and why did I mark this? Because I see a X there already. BED is X, so there's going to line X. DEF is a tangent, which means to say that angle and that angle is equal. Tan chord theorem. Find 5 and the other angles equal to X. So let's go with 2.1. So already we said C2 is X. Why? Because tan chord theorem. Okay. So then we said that B2 is X. Why? Because there's alternate angles with BC being parallel to DF. Okay. Then we can say that A1 is X, angles in the same segment. And it's coming from arc BE. Then we know that, you see here's the butterfly. So there is an X, A2 is X. Why? Angles in same segment. It's coming from arc EC. You don't have to name the arc, you know? Okay, one more. Alternate angles. So E3 is equal to X. So alternate angles with BC being parallel to DF. Okay. So there we have named 5 angles equal to X. Let's go with 2.2. It says prove that EC is a tangent to circle ADC. ADC. So if there was a circle going through here, we must prove that EC, where's EC? No. ADC. EC. Sorry, I'm looking at AB. EC is a tangent. So the question you must ask yourself, if this was a tangent, what could we have concluded? We could have concluded that angle and that angle is equal. There's a tan chord theorem. Now to prove that that is a tangent, we prove that the tan chord theorem can be applied. Okay? Alright, so sorry about the background noise there. So I just concluded now that if you can prove that is equal, we've done the job. But from the diagram you can already see that C2 is equal to, so we say since C2 is equal to angle A2, which is equal to X. Since that is the case, therefore CE is a tangent to circle through ACD. Why? It's either you write the reason as converse of tan chord theorem, or you can say angle between line and chord equal angle in the alternate segment. Okay, angle between line and chord equals the angle in the alternate segment. Okay. Okay, for number 4, we are told that ABC, so we go ABC is a tangent. Okay, so B1 is not H because it's not touching. So there's no angle. Let me just check quickly. There's no triangle where this is going against. Otherwise, I must go with this angle here. That angle and this angle is the same, as well as that angle there. That angle is the same. Tan chord theorem, no? Then we are told that EF is parallel to AC. Okay, which now means to say that this angle there is equal to that angle there. Alternate angles. and many other things. Okay, we can also say this whole angle here is equal to this whole angle there. D3 is x. Exterior angle is equal to the interior opposite. Determine with reason 4 other angles that is equal to x. Okay, so exterior angle on cyclic quad, there's your cyclic quad. So it's equal to that thing. So I can't just say angle F, because there's 1, 2, 3 angles at F. Okay, so I'm going to say B F E is equal to x. Why? Exterior angle of cyclic quad. Otherwise, you could have said angle F1 plus 2. Okay, that could also work. Alright, so there's an x. Now these lines are parallel. So we can say that if lines are parallel, alternate corresponding co-interior angles can apply. So the sum of B1 and 2, which is ABF, is also equal to x. Why? It's alternate angles with FE being parallel to AC. Okay, so there's an x here. Then triangle D2 is x, tan chord theorem. Okay, tan chord theorem. So we need one more angle. Okay, and then try and look for angles in the same segment, but that is not evident there. Just 2x, x. Try and look for another triangle here. Okay, I'm going to pause the video. I don't want this all the time to run out. And I see it. It's the bow tie. You probably have seen it way before me. There we go. That angle G2. So angle G2 is equal to x. You don't write bow tie, but angled in the same segment. It's coming from arc PE. See, this arc here is supporting angle BFE and G2. Okay. Let's look at number 6. Okay, as you can hear here, all my dragons are up. So sorry about the background noise there. Alright, so let's go with it. So we're told that BC and BA are tangents. Okay, which means to say that the length has to be equal to that length. Angle tangent from common point, which makes this angle and this whole angle equal. Okay. Then we are told that BD is a straight line. Then we are told that O is the center of the circle. CE bisect this angle. So that angle and this angle is the same, which makes this 32, so that's 64. Right. First question, 6.1. They say give the size of C2 with reason, of course. So C2 is equal to 32 degrees. Why? Okay, that's because of the Prit now. C2 is 32 degrees. Why? Because CE bisect that angle given there, which is ACB. Okay? So you have to state that. Let's look at now. So you're going to put 32 degrees here. Okay? Sorry about that now. Then it says ACD. So ACD. ACD. Okay, I'll start the next video with ACD.